we are going to be using something from the very beginning. We had, at the very beginning, I think it was like on the first page of this notes out, and we'd seen it before this section. The limit as theta approaches 0 of sine theta over theta equals 1. We are going to be using this to solve some different limits. It turns out that this is true with different arguments of your angle, as long as your angle is going to 0 and these two match. So for instance, if I had the limit as theta approaches 0 of sine 2 theta over 2 theta. Okay, if I put in a 0, am I still getting 0 for my angle? Yes. Do the argument of the trig function and the denominator match? Yes. So this would also be equal to 1. And you could have any combination of those. So if I said like sine of 12 theta over 12 theta, as long as that's approaching 0 and those match, it's still equal to 1. So we are going to use this extension to evaluate some limits we would not otherwise be able to solve. So let's look at this one. Can I just plug in the 0 for my x? No, because I get sine of 0 divided by 0. We can't do that. We know this argument, if I plug in my 0, that trig function is going to 0. In order to be able to use that property, if this is the 7 theta, what does my denominator have to be? 7 theta, or sorry, 7x. So if that's 7x, my denominator has to be 7x. So, I don't need a 4 there, I need a 7. What we can do, we know it's legal if we multiply it by the same thing on top and bottom. Okay, on the denominator, I'm going to write this as 4 times 7x. You guys agree those are equivalent? Okay, another way to look at it. Would be to totally separate that off. And now we can evaluate. The 7 over 4 is a coefficient, it would just stay. Because of the theorem, what does sine of 7x over 7x go to when x is approaching 0? 1. So this limit is equal to 7/4. Any questions there? So a lot of times our strategy on this problem is going to be reintroducing a number or coefficient into here so that we get the same argument and denominator. Okay, let's look at this one. Can we just plug in 0? No, gives me a 0 on the bottom. I know if I can get like a sine 3x over 3x, I can do it. But I currently have tangent. What could we do with tangent? Okay, so tangent 3x, that's the same as sine 3x divided by cosine 3x. Divided by x, I'm going to write that as times of 1 over x. You guys agree that that's what I started with. We haven't changed the problem. Okay, what do I need to do now? Okay, so all of this is multiplied together. We can reorganize those fractions. I could put this as the over x and the cosine over here. Mathematically, that's equivalent. If we multiply them, we get the same thing. What else do we need before we can do it? 3. So if I put a 3 on the bottom, we need a 3 on the top, right? Do I need it in this fraction? So could I multiply the 3 here? Then this goes to 1. This, we get 3 over, what is the cosine of 0? We get 3. So far, so good? Let's got another one. Any ideas on this one? Okay, sine squared means you have a sine times a sine. Theta squared means we have a theta times a theta. So we can separate those. And then as theta goes to 0, this one goes to 1 times 1. And yeah. You guys try the next one. What'd you do? So the sine 2z, we could keep the z with that, but we don't want the cosine, so we just pull it apart into a separate fraction that's on the bottom. In order for it to work, because this is a 2z, we need a 2z on the bottom. So if you had a 2 on the bottom, we have to put a 2 on top so that they would cancel each other out, because we can't change the original problem. So then our sine 2z over 2z would go to 1 times 2 over, if I plug in a 0, cosine of 0 is another one. Do we begin? Can I just plug in the 0? That's always a good starting point. Can we just plug it in? No, because the denominator is 0. Remember, limits you can plug it in as long as you're not getting 0 on the bottom. So, start separating things out. We have a sine 3 theta squared, so we could pull those apart. We have on the bottom a theta squared, so I could put a theta with each of them. And then I have a cosine, and I don't really want that, so I'm just going to put it in its own little fraction. So if we multiply this out, we get back to the original problem. We haven't changed it mathematically. In order to be able to work it, if this is a 3 theta, that has to be a 3 theta. And if you put a theta on the bottom, or a 3 on the bottom, we need 3 on top somewhere. Okay, this one also needs a 3, so we need another 3 on top to cancel it. So then that goes to 1. This one goes to 1. This one, 3 times 3 is 9. Cosine of 0 is 1. And so we get 9. You guys do the next problem. All right, what do we need? A 2. So if we add a 2 on the bottom, we need 1 on the top. So we get 1 times 2, which is 2. Right, just a couple more. what does this one need on the bottom? A 2. Now, if I put a 2 on the bottom, does this one need a 2 on top? No, so I'm just going to make another fraction out here and put the 2 there. Okay, what else does it need on the bottom? An x. Does this one need an x? It does. Okay. So, we've been using, I'm going to take a little side detour for a second. So we've been using this property the whole time. If I did the reciprocal, theta over sine theta, does it still work? So if we think about this, a reciprocal is basically 1 over something, right? So wouldn't that be the same as 1 over sine theta over theta? And then the top will go to 1, and the bottom goes to 1, and we still get 1. So this is true for the reciprocal as well. The limit theta approaches 0 of theta over sine theta is also equal to 1. So, if we can get 5x over sine 5x, it'll still work. So we've got the x, it needs a 5. Okay, so I need to put the 5 on the bottom to cancel it. So then this one goes to 1, this one goes to 1, and I have my 2/5. So our final answer is 2/5. Any questions on that one? Last problem. Okay, first question, can we just plug in 0? I would have 0 times cotangent of 0 be the square root of 4 over 0, and that's undefined. So we can't just plug in our 0. How can I rewrite cotangent? Mm-hmm. So then if we reorder it and do the x divided by sine x times our cosine, x over sine x will go to times the cosine of 0. Any questions about this stuff? So that is finally the end of this section. We're on day 3, so I gave you a few book